James Webb recently made a huge discovery on Mars. It's clear that James Webb's telescope is doing well. Thanks to the telescope, we have uncovered a lot about the universe, particularly Mars. While Mars is one of the brightest objects in the night sky, the James Webb Space Telescope recently observed one of those bright objects. Hi guys, welcome back to Not Alone, your space buddy. Today we're going to see the first image of Mars captured by JWST, and we're going to figure out how it was discovered. So keep watching until the very end so you don't miss anything. Also, if you're new here, don't forget to subscribe to our channel to get updated to every space news. Let's get started. The James Webb Space Telescope, which has a high sensitivity to infrared light coming from the red planet, has taken its first pictures of Mars. At the Europlanet Science Congress 2022, the first Mars images and spectra from the James Webb Space Telescope were presented. Webb, which was launched in December 2021 and is roughly 1.6 million kilometers from the Earth, was able to capture the sunlit side of the red planet that was facing the telescope on September 5, 2022. According to NASA, Webb will help scientists study short-term phenomena like seasonal changes, weather and dust storms, because it can simultaneously observe Martian processes that help at various times of the day. The information inferred from Webb's images help to complement the information obtained by other telescopes, rovers and orbiters that are studying Mars. The images from Mars's observable disk, or the side of the planet illuminated by the sun and facing the telescope, were taken by Webb's near-infrared camera and may offer planetary scientists a distinctive perspective of Earth's close neighbor. The data from these images can be used in conjunction with observations made by rovers like NASA's Perseverance and objects in the Martian orbit. The new images also show how the James Webb Space Telescope can study Mars using measurements made with the telescope's near-infrared spectrograph NIRSpec instrument, a method known as spectroscopy. Planetary scientists can use spectroscopy to analyze the fingerprints that different chemicals leave in the light passing through a planet's atmosphere, to determine its composition, because chemical elements absorb and emit light at very specific wavelengths. The scientists' initial findings reveal that spectral features that are encoded with details about Martian dust, icy clouds, the makeup of the atmosphere, and the kinds of rocks that can be found on the planet's surface. Water, carbon dioxide, carbon monoxide, and other chemical compounds should be detectable through JWST observations. Mars isn't the easiest object for the JWST, which was built to see extremely distant and faint objects to visualize because it's relatively close and very bright. Giuliano Luisi, a scientist and lead investigator at the NASA Planetary Systems Laboratory at Goddard Space Flight Center, stated during a press conference held by EPSC to celebrate the release of the images that Mars is so bright that the challenge is how to see it. Scientists used extremely brief exposures to study Mars in order to avoid blinding the JWST's instruments with its strong infrared light. Consequently, only a portion of the light that reached the JWST's detectors were measured, and the data was then processed using unique techniques. We have the diffraction limit of Space Telescope in the infrared, which is fantastic, and we can observe this astounding resolution. We can see the entire Earth, Luigi continued. Additionally, the Webb telescope could record events that take place during the Martian day, including those that occur during the day, at sunset and at night, in a single observation. The eastern hemisphere of Mars is depicted in two different wavelengths of light in the JWST's first images of the planet. The reflected sunlight dominates the short wavelength image, which depicts details of the Martian surface that resemble characteristics seen in visible light. These features include the Syrtis Major, Planum's dark volcanic rock, and the Huygens crater, a nearly 450 kilometers wide impact crater. The light that Mars emits at longer infrared wavelengths as it loses heat was captured by the NIRCam camera on the Webb Space Telescope. The brightest and the warmest region of this light is found where the sun is almost directly overhead the planet and is correlated to the temperature of Mars and its atmosphere. The brightness decreases in the northern hemisphere of the planet, which is currently experiencing Martian winter, and in the polar regions of Mars that receive less sunlight. However, the amount of light that reaches the JWST is not solely dependent on the planet's temperature. The chemical makeup of the Martian atmosphere and surface can also be inferred from the telescope's images. Astronomers may be able to learn more about Mars's atmosphere and surface by using data from the James Webb Space Telescope to analyze the spectrum of light that was detected coming from the planet. Luigi and his team discovered after examining the JWST images that even during the hottest time of the year, 1930 kilometers wide Hellas Basin appears darker than its surroundings. One of the neat things is you can see a dark patch that is a basin on Mars. We weren't expecting that. We were seeing something very bright, but it got darker, Luigi said. This is actually not a thermal effect of Hellas. As light travels through the Martian atmosphere and is absorbed by carbon dioxide, it darkens the area around this impact structure that has been preserved. The Hellas Basin is lower altitude and thus experiences high air pressure, the Goddard researcher explains. The higher pressure leads to a suppression of the thermal emission at this particular wavelength range due to an effect called pressure broadening. It will be very interesting to tease apart these competing effects in the data. Villeneuve and his team were also able to obtain the first Mars near-infrared spectrum thanks to the Webb's robust capabilities. The spectrum suggests more minute variations in brightness through the planet, which may draw attention to specific features of the Martian surface and atmosphere. The spectrum contained information about icy clouds, dust, different types of rocks on the surface, and the makeup of the atmosphere according to initial analysis. Water, carbon dioxide and carbon monoxide also leave their marks. Luigi brought up the controversy surrounding the presence of methane on Mars, where rovers and early ground-based observations have occasionally shown this substance to exist. While Luigi acknowledges that measurements from the ExoMars Trace Gas Orbiter (TGO) have not been able to confirm this, and that the observations from Earth are hampered by the presence of methane in our planet's atmosphere, he thinks that JWST observations could make the difference. The observational data and the rovers on the surface, he continued, have left a gap between 0 and 10 kilometers. This has been a big puzzle. With James Webb, we can now see the entire atmosphere's column all the way down to the surface where the rover is located. Therefore, we have offered a fresh approach to this puzzle. Methane is important because it can inform planetary scientists about a variety of geological processes occurring on Mars, including whether a significant object has recently struck the red planet from space. Methane may also show that there has been biological activity on the planet in the past. In a study that will be submitted for peer review and publication in the future, the NASA research team will provide more information about Webb's observations of Mars. Additionally, the Mars team is eager to make use of Webb's abilities to distinguish between different regions of the planet's surface and look for gases like methane and hydrogen chloride in the atmosphere. For peer review, the JWST team is currently writing a paper outlining its findings. So we will be back with the new updates very soon. Don't forget to subscribe to our channel and hit the notification bell